Hello everyone, this is Algebra 2, section 10.4, Definition of Logarithms. So this is a pretty exciting day for us. We're going to learn something that you probably have never seen before. There are a lot of subjects in Algebra 2 that you maybe saw a glimpse of it in Algebra 1, so even though we did some new things in Algebra 2, there was still some familiarity with what we were looking at, but for most people, Algebra 2 is the first introduction to logarithms, so it's a pretty exciting day. You may think, why does Mrs. Fuller have a road drawn on her paper? This is not a road. I want you to take a moment and just look back with me in your mind and remember when you were learning how to print. Back in elementary school, when you were first learning how to print, and your teacher handed out this really cool paper. It had like a blue line at the top and a blue line at the bottom, and it had the dotted red line in the middle. That's what this road is representing, that old elementary school printing practice paper. When we talk about logarithms, they look kind of weird. And the best way to show you how they look is to use this old paper, because when we write a log, it looks like this. It's the word log, but it has a subscript, b, for the base, and then it has whatever value you're plugging into the log. In this case, this would be the log base b of x. That's how we would say that. Oops, base b of x. And then sometimes you might even have an exponent up here. So having this old school paper kind of helps you see what this looks like in print. We've got the word log, it's normal size, then this base b is what's called a subscript, and then the x goes back to normal size, and then if you had some kind of exponent up here, that would be a superscript. So you want to make sure everything's in the right place. Those of you who have some more creative handwriting need to be careful here, because if you cannot read what you've written, it will affect whether or not you solve the problem correctly. So try to use your neatest writing with these. So you might be thinking, okay, that's nice, but what is a logarithm? So at the end of the last lesson, we looked at inverse functions, and I told you that we're going to be learning about a special kind of inverse functions. Logarithmic functions are the inverses of exponential functions. And what's cool about inverse functions is that they kind of undo each other. It's kind of like a zipper. So an exponential function, think of it as zipping up the zipper. A logarithmic function would unzip the zipper. So it's kind of doing the same operation but in reverse. That's how inverses work together. So we've studied exponential functions. Now we're going to study their inverse, which is the logarithmic functions. They are related to exponents. That's what I want you to keep in your mind. Logarithms, exponents. So when we look at these, I'm going to make a little table here. We have logarithmic form, and then we have exponential form. We can move back and forth between these two forms. So I could give you something in logarithmic form, you could rewrite it in exponential form. Or I could give you something in exponential form, you'll be able to rewrite it in logarithmic form. You can move both ways in this table. So if we start with log base 2 of 8 equals 3. If you're seeing that for the first time, you're probably thinking, what am I looking at? What is she telling me here? But let me show you how familiar this is. Log base 2 of 8 equals 3. It just means 2 cubed equals 8. Well, that's familiar. We've seen that before. we know that 2 cubed equals 8. We know that's true. So how do we get from one place to the other? One little rhyme that could maybe help you is that the base stays the base and the others switch place. So the base stays the base and the others switch place. I've been teaching that rhyme since 2003 or 4. It's been with me for a while. So kudos to my friend Angela Kilmer who taught that one to me back at Oviedo. So the base stays the base and the others switch place. So the base is this number down here in the logarithmic form. It stays the base over here in exponential form. And the others switch place. So right now the 8 is next to the 2 and the 3 is on the other side. If they switch places, then the 3 is next to the 2 and the 8 goes to the other side. So that's one way you can remember. The base stays the base and the others switch place. Let's try another one. If we have log base 2 of 16 equals 4, that means the base stays the base, so we have a base of 2. The others switch place, so the 4 and the 16 are going to swap, so the 4 comes over here, the 16 goes over there. So log base 2 of 16 equals 4. That just means 2 to the 4th equals 16. Now I have another friend who taught me another trick for her students is she does kind of a little cloud. So she does 2 to the 4th equals 16, and she kind of makes a little swoop around that way. So if you don't like my little rhyme, then maybe you like the cloud method where you just make a cloud this way, you pick up the 4, and then you move over to the 16. So 2 to the 4th equals 16. All right, let's try a couple more just so you can get the practice of going back and forth. Log base 2 of 1 equals 0. Our base is still 2. Now, all logs are not base 2. All of these examples for right now are base 2, but you can have base of any positive number except 1, and we'll talk about why in a minute, but we're just using 2 for this particular set of examples. So if the base stays the base, then the base is 2. The others switch place, so the 0 and the 1 swap, so the 0 goes here and the 1 goes here. Make sure that's a true statement. 2 to the 0 power equals 1. Yes. Or if you make your little cloud, you're going to whoop, whoop. So 2 to the 0 equals 1. All right, log base 2 of 1/2 equals -1. So same thing, base 2, and then the 1/2 and the -1 switch places. So -1 comes over here, 1/2 goes over there. And we learned in the last chapter with negative exponents that with negative exponents, it sends it to the bottom. So 2 to the -1 becomes 1/2. So let's look at the general form. Log base 2 of n equals k. If we rewrite that, we've got 2 to the k power equals n. So the base stays the base and the other switch place. So the base can be any positive number except 1, because every power of 1 is 1. So we don't use base 1, but we can use any other positive number. One that we're going to talk about later is the common log, which is base 10, and you've probably heard that our number system is a base 10 number system, so that's why that one's called the common log. All right, the definition of a logarithm. Now that we've seen how to switch these around a little bit, if b and n are positive integers, if b and n are positive, oh, I'm sorry, not integers, numbers. I was going to say, that sounds weird. Positive numbers. And b cannot equal 1. We just talked about that. The base can't equal 1. Then log base b of n equals k if and only if b to the k power equals n. So by definition, the logarithmic form can convert to the exponential form. All right. Let's look at some special cases that they may not seem obvious to you from this definition, but this definition kind of sprouts some other little tricks that we can use that may not be intuitive right away, but if I show it to you, maybe it'll make sense. So, according to this definition, I'm going to copy it again up here. Log base b of n equals k if and only if b to the k equals n. Every positive number has a unique logarithm with base b. Since the base b exponential function is 1 to 1, its inverse is 1 to 1. Therefore, and this is from your book on page 469, the log base b of n, log base b of m, equals the log base b of n if and only if m is equal to n. So, if you have the log with the same base of something over here, the log with the same base of something over here, if this statement is equal to this statement, then that means if you cover this part up, then this has to also equal this. So log base b of m is equal to log base b of n. That means that m must equal n. There are several other properties of logarithms that we can look at. If we use the definition, since log base b of n equals k is equivalent to b to the k equals n, by substitution, the log base b of b to the k power equals k. So think about this. If we wrote this logarithmically, b to the k equals b to the k. If you rewrote this in exponential form, base b, the base stays the base, the others switch places, you would have b to the k equals b to the k, which is a true statement. You're just saying something equals itself. So log base b of b to the k power equals k. The reason that's handy is because later down the road, if we have a problem that was log base 2 of 2 to the third, the answer would just be 3. Because log base 2 of 2 kind of cancels out and just that 3 is left over. By that same logic, b to the log base b of n equals n. So if we wrote this logarithmically, log base b of n equals log base b of n. You're just saying something equals itself. If you rewrote this in logarithmic form, you would keep the log, keep the base, and then this number switch places with the exponent. So this comes to this side, this goes to this side. And you can see that this statement is just saying it's equal to itself. So again, we can use this trick to simplify stuff later, because if we have 3 to the log base 3 of 12, the answer would be 12, because 3 to the log base 3 kind of cancels out and just that 12 is left over. It's not really canceling out, but it's following this property. All right, one more little trick that's going to be handy at some point. Since b is the same thing as b to the first, and 1 is the same thing as b to the 0, it follows that log base b of b equals 1. So b to the first equals b. If you rewrite it exponentially, b to the first equals b. And log base b of 1 equals 0. b to the 0 equals 1. b to the 0 equals 1. So log base b of 1 is 0. So how does this come in handy? If you're doing a problem later, log base 12 of 12, it's going to equal 1. Log base 11 of 11, it's going to equal 1. Log base 2 of 2, it's going to equal 1. If you have log and the base of these two things match, it's going to equal 1. Over here, if you take the log base anything of 1, it's always going to equal 0 because anything to the 0 power equals 1. All right, so let's practice this a little bit. First, we're going to go one way. So express log base 3 of 81 equals 4 in exponential form. All right, so the base stays the base. Where's my base? It's the subscript, so the base is 3. The others switch place. So the 4 comes over here and the 81 goes over there. The 4 comes over here, the 81 goes over here. This one is easy to check because it makes the most sense to our brains because this is what we're used to. We're used to exponential form. 3 to the 4th equals 81. Yes, we know that. If we weren't quite sure, we can verify that on a calculator. That feels comfortable to us. Moving the other way feels a little less comfortable, but you'll get used to it if you practice. So let's go the other way. Express 5 cubed equals 125 in logarithmic form. All right, so this time it's in exponential form. We're going the other way. We're going to write it in logarithmic form. Well, if you're writing something in logarithmic form, you have to have a log. So start with that. Start with your log. Then what's next? You need a base. Where do you find a base? The base is always the thing that's holding everything down. So the base is the 5. All right. The base stays the base and the others switch place. So the 3 is going to go over and the 125 is going to come. So the 125 comes this way and the 3 goes over to the other side. If you check it, 5 to the 3rd equals 125. The base stays the base. The others switch place. All right. Let's use these rules to simplify some stuff. So this is our next example. If we have log base 2 of 0.125. All right, so we haven't done anything with decimals yet. We're going to talk about how to address that in a minute. But let's talk about how you can solve this. Let's let log base 2 of 0.125 equal x. We don't know what it equals. We're going to figure it out. When you're working in logarithmic form, it's often helpful to switch to exponential form. So that's what I'm going to do first. I'm going to rewrite this in exponential form. So the base is going to stay 2, and the others are going to switch place. So this becomes 2 to the x equals 0.125. All right. Now I'm going to convert that decimal to a fraction, so 10th, 100th, thousandths. This is 125 thousandths. If you simplify that, that's 1/8. Now, if you go back to what we were doing earlier in this chapter, you remember that when we have different bases, we want to rewrite them as the same base. So if you have a 2 and an 8, you want to look at the larger number. Ask yourself, can I rewrite an 8 so that it's a power of 2? And yes, you can. You can rewrite this as 2 cubed. So this 2 to the x equals 1 over 2 cubed. I need this to come up. So whenever I need something to move in a fraction, I always change the sign of the exponent. So 2 to the x equals 2 to the negative 3. Once the bases are the same, then you can drop the bases and the exponents are equal to each other. So x equals negative 3. That means log base 2 of 0.125 equals negative 3. Now, there is a log button on your calculator. You cannot use your log button for this. We will talk about how to put these in the calculator soon, but we are not there yet. Your calculator is automatically set to the default of base 10. This is not base 10. So I'm going to show you later in this chapter how you can convert it to base 10. It's actually pretty simple, and put it into your calculator. But for now, you're just going to have to hang in there and do the algebra. All right, let's do a couple more examples. we're still simplifying. So if we have log base 1/9 of the 4th root of 3. And I can already tell some of you are checking out because you're like, what? This is not that bad. We can do this. All right, so we're going to do what we did in the other one. We're going to let it equal to x. So let log base 1/9 of the 4th root of 3 equal x. And then it's usually easier to work in exponential form. So we're going to rewrite this in exponential form. The base stays the base. Where's the base? 1/9. So the base stays the base. The others switch place. So the x is going to come over here. The 4 root 3 is going to go to the other side. All right, that's step 1. Step 2, I have a 9 and a 3. I want to rewrite these so that they have the same base. So the larger number, can that be rewritten as a power of the smaller number? Can I rewrite 9 as some power of 3? Yes, 9 can be rewritten as 3 squared. So over here, I'm going to have 1 over 3 squared. And this is raised to the x. Over here, we learned how to convert from radical form to rational or exponential form. So for this one, the base stays the base also. And then remember, the root goes on the bottom. The root is like a tree. It goes on the bottom, and the power goes on top. If it doesn't have an exponent, it's understood to be to the first power. So the 4th root of 3 can be rewritten as 3 to the 1/4. All right, we're getting closer. We need this to be at the top, so we're going to make it a negative exponent. 3 to the negative 2 to the x equals 3 to the 1/4. Base 3 over here, base 3 over here. Once they're the same base, you can drop the bases and bring down the exponents. So negative 2x equals 1/4. Divide by negative 2, which is the same thing as multiplying by 1/2. So we get negative 1/8. So log base 1/9 of 4 root 3 equals negative 1/8. All right, so all we did is we rewrote it in exponential form. Then we rewrote it with the same base. Then we just used our exponent rules. Once we had the same base, we could drop the exponents. Drop the bases and set the exponents equal to each other to solve. All right, one more to go. I want to show you how to solve some logarithmic equations. I think we're on example 4. All right, so log base 4 of 2 equals x. Just like we were doing in the last example, we're going to rewrite it in exponential form. So the base stays the base. The base is 4. The others switch place. So the 2 goes to the other side, the x comes to this side. So the x comes to this side, the 2 goes to the other side. So I've rewritten it in exponential form. Now I want the bases to be the same. I have a 4 and a 2. You want to rewrite the larger number as a power of the smaller number when you can. So 4 can be rewritten as 2 squared, and then this is going to be equal to 2. It doesn't have an exponent, so it's understood to be to the first power. Base 2 on the left, base 2 on the right. Once the bases are the same, we can bring down the exponents. So 2x equals 1. Then you're just solving for x. X equals 1/2. So log base 4 of 2 equals 1/2. Last one, log base x of 5 equals negative 1. We're going to rewrite it in exponential form first. So the base stays the base stays x. The others switch place. So the 5 goes over there, the negative 1 comes over here. All right, this one's a little bit weird. We haven't done one like this before. We have x to the negative 1 power. We want x to be by itself. We want it to be to the first power. So what we're going to do is we're going to raise both sides to the negative 1 power. So if we have x to the negative 1 raised to the negative 1, whatever we do on one side, we have to do on the other. The reason we do that is so that -1 times -1 becomes +1. So this just becomes x to the first. This is still 5 to the -1. Or if you're not permitted to have negative exponents in your answer, the way you resolve a negative exponent is you move it to the bottom of the fraction. So 5 to the -1 is the same thing as 1/5. All right, that is all the examples I have for you. Hopefully this helps clear up some stuff. Remember, there's also examples in your book. If you read through those step by step, the more you practice this, the more comfortable it will feel for you. If you have any questions, send me an email. I check my emails Monday through Thursday from 10 to 11, but I also check them at other times throughout the week. So you can send me an email anytime. I will respond to it either during office hours for sure, or the next time I log in. If you have an email waiting for me, I'll go ahead and answer it. So be sure to send me those questions. Let me know how things are going. I miss seeing you guys. I hope you're all doing well, and stay safe and healthy.